What's going on, everybody? This is Mr. Trummer, and I am going to teach you guys how to solve a system of inequalities. So very similar to the system of equations, you'll notice you have two inequalities for every one of these problems. You have all already learned and mastered graphing these inequalities. So the first thing you're going to want to do is to graph both of these inequalities. So let's start with this first one here. This y is greater than 4x minus 3. So let's graph this. All right, we want to start with that minus 3. We want to go here to that y-intercept of negative 3. That slope of 4 tells me I need to go up 4 over 1. Okay, 1, 2, 3, 4 over 1. Boom. Up 4, 1, 2, 3, 4 over 1. Boom. Okay. And then down 4 over 1, which we can't really do, but it would essentially be right there. Okay. So now we've got our line. We need to decide, is this going to be dotted or solid? Well, you've learned this week that this is going to be a dotted line. And so I come in here, I kind of do my little boop, boop, boop. All right, so that tells you that it's going to be a dotted line. Okay, and we have that boundary, of course, taken care of for that one. Then, of course, we have to shade. You guys have gotten good at shading. Again, you can either use a test point or you can simply put your finger on the line, go into the shade or the area that makes most sense. In this sense, because we are y is greater than, we are going to be above that line. Okay, so I'm going to shade in. We have graphed the first inequality. But we're not finished. We've got a second one as well. So we have to make sure we graph the second. So let's go with this pretty pink color here. That's my highlighter. Let's go with my pretty pink here. Okay, so let's graph this as well. We start at plus 3 because we've got the y-intercept at plus 3. And then we have a slope of negative 2. So that means I'm going to go down 2 and to the right 1. Okay, so we share a point there. Down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And I want to make sure I get this up here as well. Down 2 to the right 1 means I'm going to be right there. Okay. So I've got my second boundary line. This one, though, if you look closely, has the equal sign. Therefore, you're going to have a solid line where that pink is. So I'm going to go in through here and do my best to make a straight line for you. Solid line through the pink. All right. And this is greater than. So for this one, I have to be above that pink. So anywhere you put your finger, you end up going above. So we're into this area over here. So I'm going to highlight the whole thing. Okay. So I graph each of these separately. Now, you're probably thinking, yeah, but what about the solutions? We've got some areas that are pink, some areas that are blue, but then you might also notice we have one area that is both. You see this space right in here? That area right there is where you find your solution. So I'm going to put a little star here. Anywhere, any ordered pair inside that little space is going to be a solution. So for instance, if I wanted to look and I just drew a star right over it, but let's say I went 0, 5, okay, where my x was 0 and my y was 5, that would be a solution. Anywhere inside that shaded area where they overlap is a solution, okay? So I want you guys to understand that. It's not over here where there's pink. It's not that. It's not over here where there's blue. It's not that as well. It's only going to be where they overlap one another. All right, so hopefully that makes sense. I'll leave that over there as you digest that, and we'll do another one. Let's do a different set of colors here. Let's go with this purple-ish color right here, and let's make that a little bit bigger. Boom. Okay, so we're going to graph this one as well. So let's see. We've got a plus 3 for my y-intercept and a slope of negative 5, which is going to be down 5 over 1. So 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 over 1. It's going to be about right there. So probably shouldn't have used such a big slope, Mr. Trummer. But then you check here and you've got yourself a solid line, which means we have a solid line. All right. And once again, this is a greater than, and so let's go ahead and graph this as a greater than. So we're going to go above that line. I put my finger on there and went above, or you did a test point. All right, so we've got one of them, but we have to have both graphed. So I come in here, y is greater than negative 2. So y is greater than negative 2 tells me that since I don't have anything with an x, that means I don't have a slope, but I have a negative 2. Well, that means that my y, this is where y is negative 2, right? So you're going to have a dotted line right across at negative 2. And we said that it's greater than. So again, we have to come up here and we simply shade in everything that is greater than that negative 2. So now we've got all this space shaded in, but you know, because you paid attention on the last graph, that our solutions are the ordered pairs found in this section here. Once again, where they overlap. I'm going to put a big star there just because that kind of says, hey, this is the one we're looking for. This is that important spot. Okay, so any solution, any ordered pair, such as in this case, let's say 4, 1. So 4 for the x, 1 for the y. That would fall inside that shaded region. So your system of equations can be solved by a host of different ordered pairs, but they have to be where our colors overlap. All right, I'm going to give you guys about 5 seconds. Take a screenshot. 5, 4, 3, 2, 1. Kick it over to the next set. We're going to do just 2 more. All right, just to continue to give you guys some practice. So again, we have 2 different, let's go with orange this time. We've got 2 different inequalities. This one, y is less than 3. Well, very similar to my last one, only this time there's no x, so there's no slope. But again, it's at positive 3. So we know that we're going to be at positive 3. And because it is just less than and nothing with an equal sign, it's going to be a dotted line at positive 3. Dotted line across. Okay? And it's less than, which tells me I'm going to shade below. Less than, you shade below. All right? So let's shade all of this area down here. Isn't that pretty? Art class. Love it. All right, so we've got orange. Let's go with some blue. Let's bring some New York Knicks up in here. So we've got now our y is less than or equal to negative x plus 1. Well, we know the first spot we need to go is that plus 1. So my plus 1 on the y-axis is right here. And now I need to make sure that I use my slope. Now I've got a negative in front of the x. That's really a negative 1, which means I need to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, over and over and over again until you're sick of saying it and you just stop talking and draw your dots. Boop, 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 boop. But apparently I can't help but make some noises. Now, it is an equals to. So see, it's y is less than or equal to negative x plus 1. That equal to tells me that this is a solid line. So right there. And because it's less than, you're already thinking it. Well, I need to shade below that blue line right there, okay? All right, so I shade below my boundary line, and look at this. There is so much space to cover now where we have our solutions. Remember, it's where they overlap. So all of this area right down here, that's where you would find your solutions. Any one of the ordered pairs in that space. Once again, I'm going to put that yellow star because that's where we have both blue and orange. Okay, it has to be where there's both blue and orange. All right, I know I'm just kind of flying through this, but I promise you, you're going to learn it in class, and you're going to use this as just that added little piece to help you get through it. Let's see. I can't leave here without a little scarlet and gray, so let's go ahead and work with this top one. Y is greater than or equal to x minus 3. Y is greater than or equal to x minus 3. Well, that tells me that my minus 3 has to come first, so I come down here and I say minus 3, boop, and it says a positive x. This time we have a positive 1 in front, so up 1 over 1, 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 all the way across this boundary line. Okay, so we got ourselves a boundary line. Well, we're greater than, so if we're greater than, we're greater than or equal to. So if we're greater than or equal to, you know that this is going to be a solid line. that I will draw at some point. There we go. Solid line. And also, because we're greater than or equal to, we're going to shade above it. So I've got all of this space above my boundary line to shade for that first inequality. All right? And now let's get some gray in here. I've never actually used gray, so if this doesn't turn out, then I might have to adjust and change some colors up in here. All right, so we've got our gray. That's going to work perfect. Okay? So I've got gray. We're going to graph this last one right here with the gray. So y is greater than negative x minus 1. All right? Minus 1 is our, oh my goodness, our y-intercept. Our negative x tells us we have to go down 1 into the right 1, down 1 into the right 1, all the way across this graph, setting ourselves up with one more boundary line to pay attention to. That doesn't feel right. Okay. All right, so we got another boundary line, and this time it does stay as a greater than or equal to, so once again we have ourselves a solid line. Okay, solid line. And because we are greater than or equal to, we have to shade above, greater than, above that line. Now, this gray as a highlighter isn't so great, but hopefully you guys have colored enough up here. You can see that we have both gray up there and red up there. And that tells me that my solutions will be found in this space right up here. Okay? All of my solutions can be found in that space. So the overlap is really what you need to be looking for. Okay? So you have to graph each one individually, and then when they overlap, you have yourself your solution sets. Okay? So every ordered pair in those overlap spaces will be solutions to that system of inequality. So really not learning a whole lot new. The only piece is just understanding where you can find that solution. And I feel confident that everybody watching this video and everybody attending classes are able to find where those solutions are. I hope you guys are able to understand this. And as always, if you do have questions, please reach out to me. Please reach out to Miss Richard. Please reach out to Miss Ott. And definitely reach out to Miss Matt because she's smarter than all of us.